step, we will write its operator form. Operator form is written as, it's a second order derivative, so we will write it as a d square y plus, it is a first order derivative, so write it as a 2dy plus, there is a no derivative, so we will keep this one as it is equal to 0. Now collect the coefficient of y. So we have d square plus 2d plus 2 into y is equal to 0. So auxiliary equation in this case is, that is m square plus 2m plus 2. So where we have replaced d by m and y by 1 is equal to 0. Now find the solution of this quadratic equation. So we need to find a two number whose product is 2. So that is 1 and 2 or minus 1 and minus 2. What is the sum in this case? That is the 3. In this case, minus 3. But we need sum as a 2. So it means there exists no integer such that its product is 2 as well as its sum is 2. So for that we will apply the formula. So for that consider the general quadratic equation, and in this case the formula is this one in order to find the root, that is the value of x. So apply this one. So for here the value of m is equal to minus b. So the value of b is 2 plus minus under root b square, again that is 2, 2 square is 4, minus 4 into value of a is 1, c is 2 divided by 2 into a is 1, that is equal to minus 2 plus minus under root 4 minus 8 by 2. So this is equal to minus 2 plus minus under root 4 minus 8 is minus 4 divided by 2. So this is equal to minus 2 plus minus under root 4 is, that is 2, and under root minus 1 is iota. So we have in this case as a 2 iota divided by 2. Simplify this, we have minus 1 plus minus iota. And whenever we have a complex root a plus minus iota b, in that case complementary function is written in three forms: exponential, cos and sine. For exponential we need a real part. Real part is a into x, then c1, that is the first constant, into cos of imaginary part. Imaginary part is b multiplied by x plus c2 sine of b into x. Apply this formula in this case. Now what is the value of a in this case? That is the minus 1 and b is 1. Substitute these values over here and the final answer in this case is e raised to power minus x, first constant, cos of x plus second constant, sine of x. Let's answer the next question. So write its operator form. So its operator form is d square y minus 6dy plus 18y is equal to 0. Collect the coefficient of y. So we have d square minus 6d plus 18 into y is equal to 0. Now replace d by m and y by 1 in order to get the auxiliary equation. So auxiliary equation in this case is m square minus 6m plus 18 into 1 is equal to 0. Now find the roots of this one. For that, find the two number whose product is 18 but the sum is 6. So we have no two such integers such that its product is 18 but the sum is 6. So we will use the formula in this case. So we have the root is equal to minus of b. What is the value of b? That is the minus 6 plus minus under root b square, that is minus 6 square, that is 36, minus 4 into a is 1 into c, that is the 18, divided by 2 into a, that is 1. So this minus minus is plus 6 plus minus under root 36 minus 72 divided by 2. So this is equal to 6 plus minus under root. When you take the subtraction of these two numbers, we have minus 36 by 2. So this is equal to 6 plus minus root of 36 is 6, but the root of negative sign is iota by 2. So this is equal to 3 plus minus 3 iota. Now solution in this case is ycx is equal to e raised to power real part is 3 into x, first constant, cos of imaginary part, that is a 3 into x, plus c2 sine of imaginary part, that is 3 into x, and that is the final answer in this case. Let's answer the next question. In this case, operator form is d square y, because this is the second order derivative, plus 9 times of, this is the first order derivative, dy is equal to 0. Now collect the coefficients of y. So we have d square plus 9d into y is equal to 0. So auxiliary equation in this case is, replace d by m, that is the m square plus 9m, and y by 1 is equal to 0. So we have auxiliary equation as m square plus 9m is equal to 0. So do not take m on the right hand side and cancel it out. Go by step. Take m common. So when you take m common, we have m plus 9 is equal to 0. So from here we have either m is equal to 0 or m plus 9 is equal to 0. And if m plus 9 is equal to 0 means m is equal to minus 9. So we have two roots, that is m is equal to 0 and minus 9. Both are the real number as well as distinct. In that case, the solution is written in form of exponential, that is equal to first constant e raised to power first root into x plus second constant e raised to power second root into x. So e raised to power 0x means 1. So we have c1 plus c2 e raised to power minus 9x, and that is the answer. Let's answer the next question. So in this case, write the operator form. It is a d square y minus 2a dy plus a square plus b square into y is equal to 0. So collect the coefficient of y. So we have d square minus 2ad plus a square plus b square into y is equal to 0. So auxiliary equation in this case is, replace d by m. So we have m square minus 2a into m plus a square plus b square, and y is replaced by 1. Put it is equal to 0. Now apply the formula in order to get the root of this one. So m is equal to minus b. In this case, the value of b is minus 2a, that is a middle term, plus minus under root middle term square, that is minus 2a square minus 4 into a is a leading coefficient, that is 1, into c, that represents the constant. In this case, constant is a square plus b square divided by 2 into a, leading coefficient is 1. Simplify this, we have plus 2a plus minus under root, that is 4a square. This is 4 into 1, that is 4. So 4 into a square, that is minus 4a square, minus 4 into b square, that is the minus 4b square upon 2a, that is 1. So now this quantities get cancelled with this one. So we have 2a plus minus under root minus 4b square by 2. So this is equal to 2a plus minus. So root of 4 is 2. Root of b square is, that is b. Root of minus 1 is iota. When you club this one, we have 2b into iota divided by 2. So simplify this, we have a plus minus b iota. So whenever we have a complex root, so in this case the complex roots are a plus minus b iota. Final solution in this case is e raised to power real part is a multiplied by x, first constant cos of imaginary part, that is b, into x plus c2 sine of imaginary part, that is b, into x. So let's answer the next question. In the next question, operator form is 4d square y minus 4dy plus 17y is equal to 0. So take the coefficients of y, 4d square minus 4d plus 17 into y is equal to 0. So auxiliary equation in this case is 4m square minus 4m plus 17, y is replaced by 1 is equal to 0. Now what are the roots in this case? M is equal to minus b. So the value of b is minus 4 plus minus under root b square, that is minus 4 square 16, minus 4 into a, that is the 4, into c, that is the 17, divided by 2 into a, that is 4. So that is equal to minus minus is plus 4 plus minus under root 16 minus 272 by 2 into 4 is 8. This is equal to 4 plus minus. So 16 minus 272 is 256 with a negative sign divided by 8. So this is equal to 4 plus minus. So root of 256 is 16 and iota, because that is the root of minus 1, divided by 8. So we have 1 by 2 plus minus 16 by 8 is 2 iota. So in this case the root is equal to 1 by 2 plus minus 2 iota. So final answer is ycx is equal to e raised to power real part is 1 by 2 into x, first constant cos of imaginary part is 2 into x plus c2 sine of 2x. And in the next case, write the operator form, that is a dqy minus 2d square y minus 5dy plus 6y is equal to 0. So collect the coefficient of y, that is a dq minus 2d square minus 5d plus 6 into y is equal to 0. So auxiliary equation in this case is mq minus 2m square minus 5m plus 6 is equal to 0. Now this is a cubic equation. So we need to find its solution by hit and trial. So we will start from the 1 and minus 1. So when you take m is equal to 1, so we have 1 minus 2 minus 5 plus 6. So that is getting a 0 because 1 plus 6 is 7, minus 2 minus 5 is minus 7. Finally, we are getting a 0. It means m is equal to 1 is one of its solution. Now we will find the quadratic equation by synthetic division method. For more details how to find the roots of cubic equation or a power 4 polynomial, a link is given in the description that how to find polynomial roots by using a synthetic division method. So next we will collect the coefficients. So in this case the coefficients are 1, minus 2, minus 5, 6 and m is equal to 1 is one of its solution. We will keep 1 over here. Now this number as it is. Product these two 1. Finally we have 1. This is minus 1. 1 into 1 is minus 1. add these two, minus 6, 1 minus 6 is a 6, minus 6, and add these two, we have 0. In this case, we have quadratic equation as m square minus m minus 6 is equal to 0. Now, what are the roots of this one? So, we can factorize this. Find a two number whose product is 6, that is a 2 and 3. Now, place in such a way that product is minus 6, but its sum is minus 1. So, we can write it as m square minus 3m plus 2m minus 6 is equal to 0. Collect the common term. So, we have m as m minus 3 plus 2 into m minus 3 is equal to 0. So this is m plus 2 into m minus 3 is equal to 0. So finally this implies m is equal to minus 2 and 3. So final in this case we have three roots. The first root is 1, second root is minus 2, third root is 3. So finally the answer is ycx is equal to first constant e raised to power first root into x plus second constant e raised to power second root into x plus third constant e raised to power third root into x. Let's answer the next question. Write the operator form. Its operator form is d cube y because third order derivative is there. This is second order derivative. So d square y minus 4 first order derivative dy plus 4y is equal to 0. Collect the coefficients of y. So we have d cube minus d square minus 4d plus 4 into y is equal to 0. Auxiliary equation is m cube minus m square minus 4m plus 4 and y is replaced by 1 is equal to 0. Now by hit and trial find one of its solution. So if I take m is equal to 1, so 1 minus 1 minus 4 plus 4, so it is getting a 0. Let's find the quadratic equation by using a synthetic division method. So we will take the coefficients of this cubic polynomial starting with m cube. Its coefficient is 1. M square coefficient is minus 1. Coefficient of m is 4. Constant term is 4. And in this case we have root as 1. So this number as it is. Product these two 1 we have 1, 0. 1 into 0 is 0. Minus 4, 1 minus 4 is minus 4, add these two numbers, finally 0. So from here quadratic equation we have m square plus 0m minus 4 is equal to 0. So it means m square minus 4 is equal to 0. So we can write this as m square minus 2 square is equal to 0. So m minus 2, m plus 2 is equal to 0. So this implies either m minus 2 is equal to 0 or m plus 2 is equal to 0. So if m minus 2 is equal to 0 means m is equal to 2 and from here m is equal to minus 2. So what are the roots in this case? So we have m is equal to 1 as one of its root by hit and trial, and after that from here we are having root as 2 and minus 2. So final answer in this case is, because they are real as well as distinct, so that is equal to first constant e raised to power first solution into x plus second constant e raised to power second root into x plus third constant e raised to power third root, that is minus 2x.